3x threads from the last day all circle the same question. Who controls the layer sitting between you and the model? Not which model answered, but what decided how the work got done, what it actually cost, and whether you can inspect any of it. Let's get into the 3 that mattered most. First, agent delegation. According to a post from Athsotio on August 15th, Codex has shipped a multi-agent V2 feature, and the core idea is straightforward. A coordinating model no longer has to do every step of a task itself. It can delegate a subtask to any supported model in the fleet, including one referred to in the discussion as Luna, and that model handles its piece before the result gets reassembled. Worth flagging clearly, Luna is a name used in the discussion around this feature. It is reported, not officially confirmed, as a product name, so treat it that way. The concept behind this is what you'd call fleet-style orchestration. Instead of a single model carrying an entire workflow end-to-end, a router splits the job, sends each piece to whichever model is best suited, and stitches the output back together. It's the same logic as a dispatcher assigning jobs to specialists rather than making one generalist do everything. Here's why that matters if you're building in the EU. The interesting compliance question isn't which model produced the final answer anymore. It's which orchestration layer made the routing decision. That router is now the thing touching your data, deciding where a subtask gets sent, and effectively owning the audit trail. If you're deploying agent systems and you can't see or control that routing layer, you don't actually know where your data residency obligations start and end. That's the piece worth auditing before you adopt a delegation feature like this, not the headline capability itself. Second topic, and this one's about money. Also from Sotio, a thread posted August 16th walks through why token prices listed by different vendors aren't directly comparable. The example given is stark. One model needed 34.5% fewer tokens than another, in this case referenced as GPT 5.6, Sol against Claude Opus 5, to produce an identical output. Again, treat those specific model labels as reported names from the discussion, not confirmed product names. The concept underneath this is tokenizer variance. Every model has its own way of breaking text into tokens, and that means the same sentence gets counted differently depending on which model is doing the counting. So when you see a per token price on a pricing page, that number alone tells you almost nothing about what a real task will cost you, because the number of tokens needed to do that task varies model to model. Why this matters for EU teams doing procurement is fairly direct. If you're comparing model vendors on list price per token, you're comparing numbers that don't map cleanly to your actual spend. What you need instead is a cost per completed task benchmark run on your own workloads before you sign a contract. Otherwise, you end up locked into a vendor based on a pricing page that never reflected your real usage pattern in the first place. Third, and this one's a genuinely useful counterweight to the first two, Sophie Hopick flagged a GitHub repository built on LangChain, reported at more than 27,000 stars, that provides a complete agent harness under an MIT license. The pitch is that it handles the scaffolding needed to build reliable multi-step LLM agents, so teams don't have to build that plumbing from scratch or depend on a single vendor's closed tooling to do it. An agent harness, as a concept, is the reusable structure around a model. Task planning, tool calls, memory management, all the connective tissue that turns a raw model into something that can actually complete a multi-step job. Most teams end up building some version of this themselves, which is expensive and hard to maintain. Why this is the one that should actually get EU builders' attention. An MIT license means you can self-host the entire agent pipeline and inspect every part of it. That's not a nice to have. Under the EU AI Act, it's close to a requirement if you need to demonstrate transparency in how an agent system reaches its decisions. A closed, vendor-hosted orchestration layer, the kind we just talked about with delegation features, can't give you that same level of inspection. So this repo isn't just a convenience play, it's a direct answer to the lock-in risk sitting underneath topic 1. So 3 threads, 1 thread connecting them. Delegation features are moving control into orchestration layers you may not own. Pricing pages are moving cost estimation further from reality, and open source harnesses are the one lever builders currently have to pull both of those back under their own control. Worth watching which way teams actually move. That's the briefing for today. If you want this kind of grounded read on what's actually moving in AI, subscribe. And if you want it in your inbox every week, the AI Signal Brief is free and